Let me introduce myself in short. I am working mostly with really highly loaded internet projects. It's some small team. Normally our experience is to have really small amount of the really well educated and prepared engineers. And we've got quite a big experience in really big and huge Linux clusters, let's say a few thousand servers. That's fine, that's okay. And yes, it is possible to maintain all the equipment, 1,000 servers, by the only few engineers. And the only way to do that is to make some really high automation, because it's no other way to achieve something like that. As we don't like to do some really shiny presentations or keynotes, I'll try to keep everything simple, and our principle is to keep things simple but really effective. So one of the most important things for us, and for sure for any big installation, big cluster, is how to install everything automatically, because this trouble is really the big trouble. Normally, usually many companies are employing some engineers, and it's a completely manual process, because engineers are going to the data center, mounting the hardware, are going to install the operating system, but from the CD, or in advanced case or scenario from the CD, from the network boot. But there are much more interesting solutions, and as there are quite a few major players on the market for the free Unix operating systems, and normally our software is designed to run on the Linux, or either maybe Solaris, or sometimes BSD, but we're not talking about BSD now. Let's say about the Linux, it's most interesting for us, and there are only two major players on the market. It's Red Hat, it's CentOS, or commercial Red Hat, and it's a SUSE Linux, which is owned by Null now. And also one of the most interesting and new software vendors, it's some with the Open Solaris, which is quite different from the Solaris in some aspects. And this operating system is going to be really interesting, more and more interesting in recent time. And all of them, they've got really kind of commercially supported automated installation environment. What does it mean? It's a full framework, including all tools, documentation, everything else, how to automate for 100% the installation process, and pre and post configuration process, which is really important, because our idea is to be able to install the hardware, and that's all. Everything else should be made automatically by the software, and even the final step when the server is going to be loaded with some real traffic, everything should be automated. And as you can see, it's three major installation systems. It's a Red Hat Kickstart. For Open Solaris, it's an automated installer. It's no any code name. And for this use, it's a AutoYast system, which is really interesting. Okay, in case of Linux, many people are preferred to use Red Hat or CentOS. I'll try to explain why it's not our situation, why we like to use SUSE. In fact, the idea is to show some small example of the automated installation configuration file. As you could see, it's pretty simple for Red Hat. In fact, it's a bunch of scripts. So you could script anything, and it's pretty clear to read, to understand, and it's quite capable. Let's see to Solaris. It's more interesting because it's a kind of more easier to work with, more easier to understand, and especially it's more easier to automate the configuration file generation, because it's a kind of looks like XML. It's not XML, but it's close to. And finally, it's SUSE OTS system, which is completely 100% XML based, and it is possible to do anything, virtually anything, using this configuration system. I'll try to explain a bit later how everything works, and for us, after some deep testing, we made a decision. It happens 5 years ago, to use SUSE OTS system in all our project, and we are not disappointed at all. Everything simply works. Okay. In fact, when you are going to install some big cluster, the idea is always the same. You need to do some steps. First of all, is physically mount the hardware. In that scenario, the best idea for us, at least for us, it's to use blade systems, because it's much more easier to install the hardware just to insert the blade into the chassis. So it's really not complicated task, and even lowest level engineer is capable to do that. The second step is prepare network infrastructure. It's quite common situation. Okay, it's nothing to explain. It's really common hardware. Maybe Cisco, Juniper, Forstan, doesn't matter in fact. It depends on your applications. And also to prepare some additional services like DHCP, TFTP, PXE environment and everything else to provide some network boot and network installation services. The next step is everything should be installed from somewhere. In our systems, we normally named the service like a main service. It's an installation service which contain all the repository, all the updates, and everything else. So it's some centralized environment to use to install whole the cluster. The next step is profiling, which is really important. Normally for each big project, all servers are separated by the type of the application. 3W, database, cache server, media server, anything. It depends from the project, but normally it's a good idea to have dedicated hardware for each task. For the small projects, yes, that's fine to use some shared servers, but for the big projects, it's no any reason to use some resource sharing, because it's much more simple to separate. The idea is, as the OTS is capable to choose either automatically or manually which profile to use for the installation. Let's say in case you install the server with 2 gigs of memory, OTS is capable to detect, okay, 2 gigs of memory, the profile should be 3W. 8 gigs of memory, the profile should be database. Everything is automatical. It's no any reason to do something manually. But in case you'd like to choose manual profile manually, that's not a problem. And the next important thing is to have remote control, full remote control under everything. The only one way to be able to control a huge cluster is to be able to control each aspect, including and starting from the power sockets. Power sockets should be remote controllable. Let's say a PC providing such solutions, or some other vendors, it doesn't matter. There are some common protocols. It's IPMI, SNMP, IP over KVM, serial over the LAN, and it's quite a lot of names, but the idea is the same. We need to be capable to control everything remotely, and not to send anyone to the location, to the data center. And also, the good idea is to use some really smart hardware like an F5 or Juniper to choose this hardware. And the principle of choosing is to be able to use some API to modify the configuration. It's quite easy to explain. Once again, when you've got a server installed, The best idea for you is not to go to the CLI or GUI and to add server manually to the pool, but to be able to see just the traffic is coming, because everything is already configured. And for the F5, maybe you've heard before, there is a kind of API, so it's quite easy. We've got some own NOC system, I'll try to explain it a bit later, which is capable to detect that the new server is online, and in a few seconds it will be automatically added to the load balancer and also the firewall, in case we'd like to do that. It's a bit more detailed explanation of the infrastructure, which is required to install big cluster. Once again, everything is pretty extremely simple. The first principle is to separate all kind of the traffic by the VLAN, because normally it's a good idea to separate traffic and service by the type of the application, and this afterwards it is possible to filter everything, to filter the traffic between servers, and it's much more safer. And also it's a really cool to use for the automated environment, because in case you're going to install some server physically to insert it into the blade or just to connect to the switch, as it is already known which VLAN this port is belonging to, it is really easy to choose right installation profile. This is really it's a kind of small trick. One important step is for sure to provide DHCP services for network, and don't forget to use IP helper, because when you get only the 1 or 2 DHCP servers in your network, you need to set up a helper address for each separate VLAN interface on your network equipment. Otherwise, your servers they're not going to be able to see the DHCP server and to request the right data from the server. And the next important step is to prepare all the network service installation system. Is normally it's NFS, HTTP, some automount services, including LDAP, authentication and the home profiles automount, and to work under the redundancy. Redundancy is really important for sure, because when you've got something wrong, the idea is to just to repair something, but not to be in troubles. And for sure, the best idea is to use some shared storage to store all your data, I mean data for the installation services, because once again, it's much more easier for the redundancy. Next step is to think about, many people are trying to use some kind of NFS boot, NFS root. In our experience, that's fine until you've got maybe 100 servers or maybe 200 servers, but when you've got 1,000 or 2,000 or even more, it's a kind of headache. And as local drives are really extremely cheap now, best idea for us is to install operating system locally and to use a local operating system. I mean, the location, physical location is a local hard drives. It's once again, it's our experience. But also, we got really good experience with the iSCSI, because modern blade systems and modern servers are equipped by the iSCSI support in the BIOSes, and that's why for the operating system, in fact, it looks like a local hard drive. So it's much more stable than the NFS, and it's much more optimized to such services. And also, the really important thing is to be able to collect all the information from whole your cluster using some standard protocols. Normally, it's a syslog and NG, which is a really interesting solution, and it's much more better than the standard syslog. All major modern Linuxes are equipped with syslog and syslog NG, and normally it's a really good decision to use NG, because there are many advantages, and one of them is, for example, in case you are concerned about security, it's a broadcasting of syslog messages through the network, and even some intruder is going to inside of your network. It is really hard to understand where is it the syslog server located, and it's an additional step to protect your logs to be destroyed. And also, for sure, it's a really important thing to control your cluster is to have some monitoring. It's for us, it's an NOC project and Zabbix, because it's two interesting projects which are completely open sourced, but really, really powerful and capable. Okay, it's once again, since we've got a really small amount of time, I'll try to describe really in short the steps which are normally used to install some amount of the equipment. One server, 100 servers, or doesn't matter. And it is possible to do that simultaneously. So the first step is for sure to insert the blade into the chassis, okay, or to mount the server. It's the only one thing which requires the manual control, because there are no robots available to do that, but in case there will be, for sure we are going to use. And when this server is inserted, or blade is inserted, internal switch for the blade, or its external switch port is going to be enabled. And it's a SNMP trigger. And our software, it's a NOC software, is able to understand instantly that this port is enabled and the server is physically mounted and power is supplied. So the best idea, once again, as I mentioned before, it's to pre-configure ports with the VLANs, but it's not really vital, but the best idea is to do that, because the next step is it's much more simpler to detect by the VLAN which profile to use to install the server. Once again, it's a database or web server or mail server, doesn't matter. The important thing is to generate automatically proper DHCP profile, DHCP configuration for this server. Once again, it's made mostly our own software, it's an NOC project, but in fact it is possible to use some common configuration, because configuration either not differs too much, or it's mostly the same for separate servers. Afterwards, server is booting, and it's receiving the next server option for the DHCP. And as there is, it's one more trick. Normally, for all modern hardware servers, all major vendors like Sun, HP, IBM, they're always the same story. In case there is no local operating system installed on the HD drive, server always trying to boot from the network, and that's cool, because he's receiving proper options and booting, loading through the TFTP protocol all the requested data. Normally it's a syslinux software, it's a bootloader, and the part of this project is a PXE Linux, it's a PXE loader. And afterwards, AutoYast is starting and loading the proper XML file from the server. It's normally done by the HTTP protocol, but it is possible to use NFS and some other protocols. It's completely configurable. And the final step is maybe in a few minutes. It depends from the speed of the hardware. Normally it's up to 5 minutes. One server is already installed, and the installation is going to be finished. Server is rebooting. That's all. The final step, our software, NOC software, detecting that the server is already rebooted and installed. And I'm going to add this server in case it is necessary. For DBS it's not necessary, but for the 3W server it is, to the load balancing hardware or firewalling hardware all simultaneously. That's all, in fact. It's really simple, it's nice and to afraid of, and the process is, we've got some experience when we've tried to install 200 servers in the same time. That's fine, only maybe 20 minutes they've been installed and in working state. So once again, it's extremely simple. But the next thing is how to control everything. Okay, server is installed, you've got quite a big amount of web servers, but it's going to be a real headache to maintain and to control that. Okay, there are some commercial systems available, but normally they are too heavy, too complicated, and not optimized for such application, because when we've got really extremely highly loaded internet project, each % of the CPU usage is important, and when you've got some really monolithic and big centralized management solution, normally it's really too heavy. Even own novel solution for the use is too heavy. They've got some solution. So there are some ways. Some companies are using something really simple like a parallel SSH. What does it mean? It is possible to type some CLI command and to send this command simultaneously to 100 servers. Or 10 servers. Doesn't matter. It's just a highly modified SSH version. Also, we've got some own solution. It's MSSH, which is much more smarter, but it's not open sourced, unfortunately. So I'm not eligible to describe some details. And also, there is a XCAT software, which is extremely interesting. Definitely it's worth to look at. That's because it's a IBM-made software, and the next slide I'll show you why. And also one more interesting project. It's a new generation of our own solution. It's a NOC project, which is completely open source and is available to download, and it's really cool because it automates mostly virtually anything. It's and in case it's not automating something, it is really easy to add support, because software is written on Python and it's extremely configurable and extendable. Okay, this is an IBM XCAT. It's a tool set for maintain, to install, to provision extremely big clusters. As it's a kind of commercial thing, it's open source, but it has commercial support. The functionality is really big. You could see it's even supporting virtualized environment, and also Windows systems and many other things. But for us, it's overkill. That's because we are only using, normally using Linuxes and maybe Solaris. That's why, as it's quite complicated to set up and configure, it's not extremely complicated, but you need to work on. We've made a decision to develop something own, and we've got some NOC project. NOC means NOC, so this software is a kind of thing to control from the single point everything. Installation processes, it's a bit damaged, okay. VLAN, provisioning, DHCP, DNS, anything. And once again, it's really extremely easy to add some features or to request some features, because in fact, the developers are working in our company and they are really open-minded, and normally, in case the feature is interesting, they are always trying to do something interesting. And this is one funny thing. As I mentioned before, it's really important to have some redundant configuration for the installation services. And the funniest thing is that now it's much more interesting and stable to use open Solaris like installation server. Simply that because there are some unique technologies built in, especially ZFS, which is the best file system ever, for many reasons, and also it's an open Solaris cluster solution, which is extremely interesting. It's honestly, it's much more interesting than Linux heartbeat technology. It's much more advanced because initially it was a commercial solution. Finally, maybe 1 year ago, Sun was made a decision to open the solution for free. And it has so much unique features, and some of them are really important for us. Let's say, once again, it's a heartbeat, highly available NFS, HTTP services, DHCP, DNS, TFTP, everything. And for example, in case of highly available NFS, in case one server in cluster is going down or just blowing up, it's only a matter of maybe a few milliseconds to switch over, and even you get the mounted NFS file system, and you try to copy some data. It's just small stall, and everything continues to flow. But by the way, you need to be aware about the NFS 4 because it's a really hard to achieve the redundancy with the NFS 4 because it's a state protocol, and in the such situation, it is when the failover happens. By design, client should dismount and mount file system once again. That's why we are normally using NFS version 3 because it's a stateless protocol, and it's really fast to switch over, especially in the situation when it's a UDP. TCP is better normally, but for the failover, UDP is better. And also it's a zones support. Zones, it's a kind of virtualization which is really extremely flexible and much less resource hungry than the normal virtualization like Xen or VMware, because it's a kind of maybe really advanced cache route technology. And for sure it's a famous stability because personally I've got some installation with Solaris with they are more than 10 years old. Everything simply works. It's a really a kind of a fun. I'll try to describe for sure some, it's not maybe bottlenecks, but it's a mix of tricks and bottlenecks. First of all, for sure, all data should be shared. It's quite easy to understand, once again, because in case you're working with a huge cluster and you've got only a small amount of good engineers, it's really important to be redundant and to stay alive. It's keep in mind, bear in mind, everything should be redundant, at least for the centralized environment. And the second thing is to try to use as much open source technologies as you could afford, because for us it's much more easier to either employ some smart guy to fix something, or to at least to do some sponsorship to request to fix some troubles in case there are some troubles. Because normally for the big commercial companies it's much more complicated process. Even in case we're going to buy official SUSE Linux, novel SUSE Linux support, normally it's quite complicated and one procedure to ask them to fix something, and it's much more easier to employ a few guys, few kernel hackers, and they are really smart, and it is possible to fix anything virtually in a few minutes in case of emergency. For sure, we've got quite a lot of glitches before with the network environment, especially unfortunately with Cisco hardware, and there are some funny situations. Let's say in case you're going to use 3000 series Cisco switches, and you'd like to use jumbo frames. It's a frames which are bigger than the standard one. You need to remember that in case you're going to use SVI interfaces on the Cisco 3000 series and jumbo frame, everything is going into the software, switching from the hardware to the software. For sure it's a big trouble in case the traffic is big. And normally such things are not really well documented. And it's quite a lot of other things happens in our experience, and that's why currently we are trying to work mostly with Juniper and Force 10. But it's our own decision. and it depends from the requirements, because normally in case of the traffic is lower than 10 gigabits, everything is fine, even with any kind of equipment. And once again, really important for us, for example, we've got one platform in the Miami. It's quite a big, it's hundreds of servers, and normally we are visiting these facilities once per year, because it's no any reason to be physically to be inside of the data center, and in case of hardware failure, it's much more easier to send maybe some engineer to replace something, and we've got full control, IP cameras, IP phone on site, and everything else, and we are looking at when someone is doing something. And also in all other scenarios, in case of software failure or something like that, we've got full control, including the power sockets, to do anything with the hardware. The only thing to send someone physically is hardware failure. That's all. And our idea is to employ less engineers, but the quality of the engineers should be much more higher than normal. And in our experience, it's a few thousand servers. It's maybe 4 or 5 engineers only in the technical team. That's all, and that's enough. In case they are not working with internal company IT equipment, I mean office environment and everything else. So I think. In short, everything is explained. Once again, I'm not trying to provide a huge amount of the information. It's just initial view. And I need to say everything is already proved many times. We've got at least 5 really highly loaded internet projects with tens of million users and really big installations. But it only maybe first look that everything is complicated. It's not complicated. It's really easy to use, really easy to install, really easy to maintain. Just it's a matter of proper technologies, right technologies, and to look in advance, and also to be a bit wider. Many companies and many engineers, the trouble is they are mostly oriented on into one solution, one vendor, like Cisco is best, Microsoft is the best, or something like that. The idea is to use the best technologies from all majors and to mix the technologies, not too afraid of, because the world is moving ahead, and it's always something interesting. And sometimes, in case we've got mostly finished solution, but there is a new solution available which is much more interesting, much more cooler. It was a story with the F5. We've tried to use Cisco solutions, it's ACE and CSM, but finally we've tried to use F5 VPN, and it's unbelievably better. And even in case of really dangerous situation for us to switch everything over on the fly, we've done that, and we are really satisfied and happy. So don't afraid to work with the big clusters, big installations. Everything is really simple. Okay, maybe someone got some questions.
Prosimy o podawanie sobie mikrofonu.
I got one question regarding Zabbix. How many times are you monitoring using this software?
Zabbix is a really interesting piece of the software. We've tried to be sponsor for many features for the Zabbix developers, and current situation is each server, the amount of monitored parameters is in about 80 parameters per server, and totally it's up to 3,000 servers. It's not a problem, because Zabbix has really smart technology. It's like a proxies. So it is possible to install Zabbix engines which are collecting the data, joining the data, and only afterwards sending the data to the central Zabbix environment. Zabbix is a really good monitoring tool, and definitely it was to look at it because it's so much better than the Nagios and the Nagios successor.
Okay, but do you have some problems with performance of Zabbix?
Yeah, it was some amount of because it's open source software, for sure. There are always problems happens, but mostly for 99% everything is stabilized now, and for last maybe 6 months it's not any single issues.
how many machines are running Zabbix servers and
For
database
now,
is split into separate server? Or?
Once again, there are few massively big central servers for Zabbix. It's a database service and also some management server and some amount of proxies, but I don't remember how much, but I think not big amount than 5 or 6.
You always mention that you are using blades, it's true?
No, it's a mix of, for now, for example, the one of the best technologies is HP blades technology and also Sun blades, which is new chassis available. It's more than 100 blades per chassis, which is extremely high density. And but we've got maybe a few thousand of standard Sun servers. It depends from the price and efficient and the current economical situation, because sometimes vendors are really happy to provide 80% discount. Why not to buy it? Because it shouldn't be any kind of restriction. So we've got quite a big mix of the vendors, but mostly it's a Sun and HP, and also for now it's Juniper, Cisco, and Foston.
And you are not experiencing any problems with HP blades?
Sorry?
You are not experiencing any problems with HP blades? Do you not have to reinsert servers or update firmware frequently?
Once again, the idea is not to use HP tools, official HP tools, because in case, especially in cases those tools are made for a Windows environment, it's really extremely highly problematic. But in case you've got some own solution, we've got HP blade support, which is built into the NOC project. And NOC is able to upgrade firmware by the IPMI and FTP and TFTP. So yes, we've got initially some troubles with HP blades, but for sure there is always a way to avoid such troubles. And finally, we found the solution. But yes, it's completely new technology. Technology is really interesting, but personally, in case you'd like to be more stable, the idea is to use standard one-unit servers.
Okay, thanks.
Może jeszcze jakieś pytania? Czy...
Okay, thank you so much.
Teraz zapraszamy na 15-minutową przerwę i o godzinie 15:50 będzie kolejny wykład.